Okay, so who caught it? Who caught the major shooting bug? You know, the one that makes you do crazy stuff like, see if I can replicate it here. Shoot behind you. Did you guys figure that one out? I'm sure somebody did. So why do you guys think this is happening? Can you just trying to replicate it on the character here? You can sometimes get it to happen, but you definitely get it to happen in this right here. Do you guys have any idea? Well, it's because the crosshair is behind the character, the object that the crosshair is pointing at is behind the character. So how we set up the projectile is that we basically give it an angle to go to once it leaves the muzzle. And once it leaves the muzzle, it's kind of like on autopilot. It's like a rocket. It's like a true projectile. It is a true projectile. And it's heading toward what the crosshair is pointing at. Well, as you see, this thing here is recessed. So therefore, it's behind me. So it's sending it at an angle that is behind my character. And this would be, bad news here. So what we need to do is we need to find a way to determine when this is happening and tell our character to shoot straight out of the barrel and to totally disregard the crosshair. In addition to that, we want the player to know that his crosshair is no longer the point he's going to be shooting at, so we're also going to dim the crosshair out. So it's kind of complicated. It teaches some math principles that I'm probably not qualified to teach, but I know it works. So let's begin. Let's go into the third person character, and I could start one of two ways. I could do the I'm just going to do the shoot to calculation. So that's our calculate actual. We'll need to go to where we're firing, which I'm looking for again. Okay, so this is our calculate shoot to. Okay, so what we need to do is we need to find out if what we're shooting at is behind us. So, and then remember, this is your calculate shoot to, not your shoot actual. So on our impact point here, we want to subtract it from another vector. So let me bring this out here, hit the minus key. So vector minus vector. Great. Then we want to get our shoot muzzle location. So I don't think I ever put that in here, and it's pretty simple. It would be that value right there, and I might just go ahead and clean it up since we're right here. I'm just trying to get the value that's coming out of here. Only I want to get it as a variable, so it's a little cleaner. So you can promote this to a variable. And I'm going to call it shoot muzzle location. And the reason I call it shoot muzzle location is because this is the value of when you're actually shooting as opposed to when you're checking. So that's why I named it shoot muzzle location instead of check muzzle location, because they're very similar things, and I don't want to be getting confused. So what we're going to do, what you could do is you could take shoot muzzle location, and I might do this on my own, is you can get the value here and plug it into each one that this is coming out of. So here, you know what, might as well just do it while I'm talking about it. So just plug it in here, and be careful, make sure you're actually getting the right ones. Shoot muzzle location. It clears up your, see all this stuff going all over the place, and they're both yellow, so it would be easy to mess this up if you didn't do what I'm doing. And then finally, shoot muzzle location should go right here. Look at that. We cleared up a lot of mess there. Okay. So, now that we have that set, we're going to need it right here. Put your shoot muzzle location. Okay, so your impact point and your muzzle location, and you want to normalize these two vectors. So type normalize, nope, not normalize vectors. Okay, and then from there, you're going to want to get the dot product of this value and the forward vector of our sockets of our socket here. But you notice we have a small issue, and that is that you can't get the forward vector of a vector. It has to be of a few different things. But if you type in get socket rotation and type in muzzle, then from here you can say boop, get forward vector. Okay, and that will give you something to compare this normalized value against. Okay, so you have your you're just getting your muzzle's rotation, and you're getting the forward vector, getting the dot product or the dot of the shoot muzzle location and the impact point. That difference normalized. And then finally, what you want to do is you really want to determine something about this value. Let me show you what this value shoot now. So let me just do a print screen. Run it in here, and this is going to make a lot more sense. Okay. All right. If I did it right, value should be shooting out on the screen well, shoot out regardless. Okay, let's see what the value is. Okay, negative. It only came out for a second. Let me make it a little longer. Let's make it 5 seconds. Okay. So he goes to shoot. Negative 0.84, negative 0.85, negative this, negative that, negative this, negative that. Out of here, positive numbers, negative numbers, negative numbers, negative numbers. Okay, so you see right there, you're going to make a decision based off of whether it's negative or positive. Even better than that, you get goofy angles. This might not be the best way. You can get some really weird. I'm going to see if I can get it. Maybe I can't remember how I was doing it, but trust me on this. You can get some very strange angles based off of how we have things set up, and so where it's not like necessarily going behind you, but it'll be going sideways in a very, very strange way. So what I did is I kind of made a guesstimate. Just a trial and error method way of determining what my tolerance was. And I called it, what did I call it in my notes? Strange angle tolerance. And I wanted to check if it was less than that. So let's go ahead and drag off of this right here and say less than. Float, less than float. And this value here, that's the one we're going to promote to a variable. And we're going to call it strange angle tolerance. Okay. And so the closer to 1 you get, and I know you just looked at it, but in case you didn't get enough time to really stare at it, the closer to 1 you get, the more dead on your shooting is, the more accurate, the more natural it is. The more toward 0 and negative, the weirder it gets, and at negative numbers, it's going behind you, which is not what you want. So you want to set it to a certain value that's like, okay, past this value, it's shooting pretty normal. We'll go ahead and say that's acceptable. So for my strange angle tolerance, I thought 0.3 seemed reasonable. This could change. This very well could change. But for right now, it's a good spot to go, okay. This is acceptable. So I'm going to delete my print screen since you saw what was going on, and make a branch. And so based off of here, we're going to make a decision. And I'm just looking at my notes to see what that decision is. Well, I know what it is. It's just how to word it in a way that makes sense. So I'm going to change how my gun shoots. Instead of going to a crosshair, it's going to go straight out of the barrel of the weapon. So that way I don't have to worry about what that crazy direction of my crosshair is. If it's in this zone here in the strange, if it's less than the strange tolerance, which is 0.3, it's at a weird angle, and it's eventually, if it gets low enough into a negative number, it's going to go behind me. So if that's the case, I want to do something. Otherwise, I'm going to just pretty much continue business as usual. Okay? So this is only if it dips down below that value. So to get it to shoot straight out of your weapon, we're going to call that forward vector again. So go off of the muzzle's rotation and say get forward vector, because we want to know it's straight out of the gun, but what we need to know is how far. So we come straight out and multiply that vector times a float, just like our line trace. 10,000 will work. And then we also want to get our shoot muzzle location. So it's going to have this added to that value. So drag off of here, plus vector plus a vector. Okay, and sometimes it's easier to see it straight out. So get forward vector of the muzzle times and I don't know why, but this makes more sense to me when I arrange these differently. Okay, so if I get my forward vector times 1,000, and then add to it my shoot to muzzle location, I should go ahead and find the look at rotation. Okay, and this is actually going to be the target. Okay, so this is going to be where it's going, but we need to find out where it started. And so it came from our shoot muzzle location. Okay, and then from there we can make our transform. Don't worry, I'll go back over this, because I know somebody's head's just about ready to, go crazy. Okay, I'll make sure I got my notes right. Shoot muzzle location. It's called once again. Okay, so what the heck are we doing here? Okay, so we're getting from here. Remember, our muzzle's location and our muzzle's rotation. Those are what those values are. Basically, look at this as your muzzle's location, shoot muzzle location, and the rotation. So we had to get the rotation to get the forward vector. So it's going to be the most x vector of the muzzle. So we're going to get the x of the muzzle, and we're going to times it by 10,000, and we're going to add that to our muzzle's location to get our target. So basically, target is straight out of the gun at this point. Wherever the gun points, that's our target. We don't care about crosshairs when our angles get crazy, because we can't trust them at that point. We're going to say the start of this rotation that we're trying to find is at the muzzle's location, okay? And then from there, we make a transform, and look at this. This is our shoot to. It's our new shoot to, okay? So what we need to do is, since we have shoot to coming out like this, we really don't need to do this. I did this so for ease when you're looking at the function from outside of here. But what we're going to do is we're going to get our shoot to, and we're going to set it. And this is I think this is going to be, yeah, based off of this value being true, right? So only if our value gets freaking crazy and weird, which is what we set up with this spool, we come off of here, oops, we come off of here and say, okay, we've set it. But remember, you can pull the value out, because that's the whole point of all that. You're setting the value. Okay. So let's get some notes in here so we can start understanding what's what. This part here, add a comment. Checks if you're shooting behind yourself or at a crazy angle. So, or at crazy angle. Okay. This here, if at crazy angle, or if, like say, if shooting behind self, make, I'll put this one in quotes, shoot to, shoot from muzzle. And I should say shoot straight from muzzle, because all of our stuff, you know, when you're shooting towards the center of the screen, it's angled, and unless you get your angle set up right, you'll notice that you'll see a definite, okay, dude, I'm shooting at an angle. It's very, very strange looking, but and you really only notice that when the laser's on. But most games, they're doing that. They're firing from the muzzle or from the front of the character, and they're angling the projectile to shoot toward the center of the screen, because that's where the crosshair is at. So it's kind of an illusion, really, with how the shoot to is set up. Okay, so this, I believe, let me check my notes, might solve the shoot to problem. Let's just test it out instead of looking. So I got my server here, and we'll have to remember to check our client. So he goes to shoot. Okay, he's shooting into the mesh, and you can't really tell. So what we need to do to be able to check our work is that thing I deleted off the dot product. Let's go ahead and drag this off and say print string, sorry. Get it out of the duration, put it into the in string, so you know that's what you're actually seeing. And make a little room here. You can move this guy out of the way, whatever you got to do. All right. compile, save. So if you get a negative value and it's not shooting behind you, you know you've done it right. So we got a negative value and he's not shooting behind himself. He's actually, okay, we're still getting negative values and he's shooting straight ahead. There was one thing I wanted to try. Yeah, here's another example. So since the character is behind, where the crosshair is pointing is behind, at a point behind the character shooting, it's doing a negative number. And that negative number would have sent the projectile back into the guy's head, which is not what we want. At this point, if he's shooting, his projectiles should be coming straight out of the weapon. And so we've known so far our coding has been correct and he is shooting as he should. However, it would be very difficult, well, not very difficult, but it would be to the user, it wouldn't be fair to say, hey man, I got my crosshair right on this guy and he's not dying. I think what we should do is at least gray out that crosshair. So that's what we're going to do. We're going to add a little bit of code into our shoot actual. That's going to clean all that up. So let's escape out of here. This is our shoot 2. So let me go to our event graph and don't get these confused, dude. And you can tell because one's off the tick and one's off the fire. So our shoot actual is off the tick. Let's see. Calculate shoot actual. Double click on that. And basically, there's going to be a lot of things similar. So let me go back into my shoot 2. Let's grab some of this code here. Control C. And let's go into my calculate shoot actual. Drop it in here. Okay, and we need some values because it's going off of different ticks. So first one is going to be check first impact point. And we do have that variable. So I can just go check first impact point. Okay. Minus check muzzle location. And remember, when we're in the actuals, it's always checking because that's how we know where our crosshair is at. So it's always checking. And then we got to get the forward vector off of our muzzle and its rotation. We have a variable check muzzle rotation already set right here. So we can just grab that and throw that on. Okay, so we get the dot product and our strange angle tolerance, it's going to always be the same. And then we want to make a decision. And this one's a little more complicated because of where we have to make this decision. And it needs to be done before we get to the second line trace. So I gotta find a way to move all this stuff. Let's move this over. Okay, take our second line trace and all of this stuff right here. Move it over. Right there. Okay, press B, left click. Let's put that in there. And the false node is going to connect here, but okay. So remember, this is checking if you're shooting behind yourself. If you're not, business is normal. You're just going to go right through here. But if you are going to shoot straight out of your muzzle, a couple of things need to occur. First off, your crosshair needs to go gray, but also your laser needs to shoot straight out of the barrel as well. And we have yet to do any sort of line trace out of the barrel. So we're going to have to go ahead and set all that. And my computer is going crazy. Don't restore. So how to do that? First off, we're going to say that we can assume that our different targets are going to be true, right? Because this is the whole reason that we can't trust our crosshair. It's going to be it's trying to shoot behind us, which is ridiculous. So we can't trust it. We're setting our different targets to true, which changes a bunch of stuff down the road. Then we need to do our line trace. And this line trace is for straight out of the muzzle. So what we can do is we can do check muzzle location. And we can start it right there. That's pretty easy. And then we can use, where did I put it? I'll just write it out. It'll be easy enough. So check muzzle rotation. Let's get that. Got the check muzzle rotation. Go ahead and get its forward vector. Multiply that. Vector times a float, just like we did before. 10,000. Okay, and then we want to add vector plus a vector. Once again, I like it to be like this for whatever reason. It makes sense in my head that way. We want to add these values and then spit out over here, and that's our end. Okay, set your trace channel to projectile, and how did I set that? We don't need it on for right now. Okay, you could do, if you want, even though it already says ignore self, we can just copy this here, Control C, Control V, drag that right there. Just make sure we have our projectile trace. Compile and save that. Okay, so we have our start and end of our line trace. Now, regardless of what happens from this point on, we need to say check muzzle rotation. Let's get that. And we need to set our laser rotation. I don't know if we've used that yet, so let me see. Laser rotation, yes. So set our laser rotation to our muzzle's rotation. And how do I know that? Well, it's because the laser is going to be pointing straight out of the barrel, so you can assume that the laser is going to be in sync with the barrel, since that's where everything is going. The projectile, the barrel, or wherever the barrel's pointed, that's where the projectile and the laser is going to go in this scenario. So then at this point, and that's going to happen regardless if we hit anything or not. If we're shooting straight up in the sky, the laser is going to be pointing straight up. If we hit a guy in the head, it's going to go straight to the head. That's how that's going to work. So check muzzle rotation goes into your laser's rotation, and then you want to break this result. Okay, and we want to set our impact actual, because, let me see here, set impact, wondering why that's not working. Set check impact actual. Okay, there we go. And then just go right up to your impact point. Okay, and that'll be if you have a true. So if you hit something, that's going to be your impact actual, because, well, that's, if you hit something, that is your impact actual. Okay, that's the actual location that you impacted at. And the reason we have to set that is because we use these variables later on. Now, if you don't hit anything, you're going to need to fake where you hit. So Control C, Control V. You don't actually have an impact, but you still need to plug a value into here because it's looking for that to determine how long the laser should be. And I think one other value. And that is just going to be as far as you can possibly shoot, which is this right here. It's the end of your line trace, that value. It goes right in here like this. And then from there, you continue on the function. Now this should automatically continue. These both should continue on, but for clarity's sake, I just drag it off like that. Well, if it lets me. If it doesn't really matter. There you go. I think that's it. Compile, save all, and now let me check on my notes here. That might be it. So let's give it a test. So I go over here, pick up my weapon, I get behind him, there he goes. See? It turns off, and my guy's shooting behind me. The only thing, I'm not really seeing the laser. It's kind of hard to tell because it's shooting straight out. Oh, there it is. It's just hidden. And let me turn on the full thing. On Weapon X, see, I had owner no see on that laser beam. I just had it for the laser light, so just turn off owner no see. I kind of like it just with the laser light. But anyway, there you go. And I don't know if you can see it or not, but the laser beam is there. And I'm using the dark one so you can see it. But it's going, see that? Yeah, that's working perfectly. So when it's like, I would shoot behind myself, now he's shooting on the path with the laser. And you might ask yourself, well, he's not shooting exactly with the laser. Well, obviously he's moving faster than the bullets. And so this is the whole reason we set these sparkly, crazy things. If you had your bullets going at full speed right now, you would have probably never caught the projectile going behind you until things behind you started getting damaged. And if you had the projectiles set to ignore yourself, then you would really have a hard time figuring out, unless somebody was like right beside you or right behind you, or something weird like you were doing a grenade launcher and it was firing off behind you. That'd be the only way you would ever know. Now, well, that's working properly, but we already knew that. Now you know, okay, this crosshair is no longer valid. He's not shooting behind himself, but you know, okay, he's shooting straight forward. He's not going to hit where that crosshair is at. So anyway, I think I've just about covered it. Now, inevitably, there's going to be some bugs, man. That's just how it goes. There's going to be some, obviously there's touch-up stuff like the angle of the character to the laser and all that. And we're going to fix up how the projectiles look. I think at about this point, we can go ahead and speed them up to normal speed and add all the cool particle effects. But there's gonna be little things, so we'll address them as they come up. So far, this seems to be playing pretty good. No problems, at least that I can see. But I'm only checking the server, so I just broke my own rules. So I'm gonna run it as dedicated. Press play. Make sure all of those things still worked. Yep, there he goes. You can see the laser beam. I'm going to set it on owner no see false, so I do see it. And those are the same bools that we see. Yeah, that's working right. Client. Yeah, I could brighten up maybe the laser beam a little bit, or the light point actually. Check over here. Yeah, it looks pretty good. Inevitably, there'll be some little bugs, but we will get to them. We will fix them. and then we'll proceed from here. Don't worry, we won't be stuck on crosshairs forever, but think about it. Like this, now that this is set up, we can do anything with this. We can identify what we're going to shoot all the time. Our muzzle's always going to be shooting at the right thing. It's not going to be doing anything crazy. We can use the code that we've set up to display like names of people that we come into contact with, or things that we're going to pick up, items that we're going to pick up. All of this data can now be collected. Now the stuff starts getting funner, or more fun. So it does take this initial grind of getting this coding done, and this time it was more math intensive than normal. But don't think for a moment that I came up with these math equations. I hunted and found similar equations and then plugged in my variables to the best of my ability where I thought they would go. I didn't come up with this. None of this stuff. So if you're scratching your head, do what I'm going to do. I'm going to get a book on 3D math, and that way I can come up with these types. When I come into a problem, I'm going to be able to solve these types of problems without having to go look online around. But hey, if you have to do that, I did. Do it. Get these math equations down, because if you're going to be doing, especially in this third person scenario, you got to make sure that your projectiles aren't shooting behind yourself. But yeah, that's pretty much it for this episode. I'll see you guys in the next one.